Alright, the last material we're going to look at for the course is exponential and logarithms as inverses of each other and how to use these. So we want to get to where we can solve and do things with logarithms. So to do this, let's first talk about exponentials and inverses a little bit. So we've dealt with exponentials before. An exponential function with a base of a is just in the form f of x, remember that's my function notation for y, is equal to a to the x. So here f of x equals a to the x. We know this is the base and this is the exponent. So it says a has to be bigger than 0, so that means it has to be a positive number, and it also can't be 1. Alright? So we have looked at exponentials before. Now what we're going to do is start looking at exponentials when the base is known, but the power is not known. To do this, we're going to need logarithms because exponentials and logarithms are inverses. So every major mathematical operation has an inverse, and we've talked about a lot of these before, and mostly these are done to solve equations. So whether you had 105 sorry, or you started in 111, you've heard me talk about before inverses and undoing operations. The first one, for instance, if we have addition, we know that its inverse, or the operation that will undo it, is subtraction. So an example, if we had an equation like x plus 2 equals 9, in order to solve for x, we need to use the inverse operation of adding 2 and subtract 2 from both sides to be able to solve and get that x is 7. So we know that addition and subtraction are inverses because they undo each other. We've also seen before that multiplication and division undo each other. If we have something like 2x equals 8, if we need to solve for that x, we need to undo the multiplication 2 times x. So we would divide both sides by 2 and get x equals 4. So we know multiplication and division are inverses and undo each other. And more recently, we've learned that powers and roots are inverses. So you remember we looked at equations like this. So if our variable was raised to a power, the inverse of the power was to take the root. So you remember that we took the cube root of both sides to get that x by itself. So now we're going to start looking at exponentials, and it's going to be stuff like 2 raised to the x, and we're going to need its inverse operation to be able to solve for that variable, and the inverse operation of an exponential is going to be a logarithm. Alright, so we need to start introducing and looking at some of this stuff. So the logarithm base 10 of x is defined by and written as log base 10. Notice that this is a subscript of x equals y. So remember, we were talking about logarithms and exponentials being inverses of each other. So if I have this log 10 of x equals to y, I'm going to show you a little trick that I'm going to use a lot. If you put your pencil on the base 10 and draw an E for exponential, to rewrite a logarithm as an exponential, we would start with that base. Shouldn't have written it like that, sorry. Start with the base. It's raised to the power of y equals x. So I'm following this around. We start with the base. It's raised to the power y equals x. Okay? So we're going to need to be able to go back and forth between logarithm expressions and exponential expressions, and this is the way we do it. So the idea behind this is, if we're given log 10 of x, that should equal to the power that I need to raise 10 to in order to get that input value of x. So that's what we're trying to solve for. Now you'll notice in the calculator, textbooks, if you see it, log base 10 of x is called the common logarithm, and it is usually written as just log of x with no base showing. So if you see log and there's not a base showing, it's always an implied base of 10. Okay? So what we know is log base 10 of x is the inverse function of 10 raised to the x power. Alright, for this next part, I want you to pay attention to the instructions for the problems that we're going to be working in this section, because they make a difference. You notice this says rewrite the following logarithms as exponentials. So we're not solving anything here. We are just going back and forth between the two forms. You remember I told you that we're going to need to be able to go back and forth between the logarithm form of an expression and the exponential form of an expression. So that's what this part is about. All we're doing is rewriting it the other way. So to do that, we can use what we learned up here. It says log 100 equals 2. So we know it has an implied base of 10. So to rewrite that as an exponential, you start with the base and follow it around. So the base is 10 because it was an implied 10 there. It's going to raise to the second power equals 100. And notice that that is a correct statement. 10 squared does equal 100. So that lets you know that you've rewritten these correctly, because we got a true statement. Okay? So this one is also a base of 10. So we do the same thing. We always start with the base and go around. So we have base 10 raised to the power -1 equals 1 over 10. And again, that is a true statement. 10 to the -1. Remember, a negative exponent makes us take the reciprocal. Okay? And then this last one also has a base of 10. So we know we have base 10 raised to the power of x is equal to 75. And again, that's all we're doing here. We're just rewriting them. We're not trying to solve or get any kind of answer. Okay? So for this next section, now we're just going to go in the other direction. Okay? Now it's going to be given as an exponential, and we just want to rewrite it as a logarithm. So again, we're not going to be solving anything. We are just going to rewrite it in the other form. This one also has a little thing we can use. The word logarithm starts with L, so we're going to make an L this time. So I'm going to start here and then go back like this. So I know it's not exactly an L, but it's something that we can use, right? So we're going to rewrite this exponential as a logarithm. So I need log because we're rewriting it as a log. That first thing that it touched was the 10, so that is my base. And then we went across. So we're going to put the 10,000 here. And then we go back is equal to the 4. So what we're doing is the last problems we looked at, they were given as log. So we wrote as exponential. And then these are given as exponential. And we're writing as log. We're just going back and forth between the two forms. That's all we're doing right now. Okay? So if we do this one, I have log, my base is 10. Then we have 1 over 1,000 equals -3. And then this last one, we're going to do the exact same thing. I get log base 10, 5 equals x. Now you remember I told you that log base 10 is my common logarithm, right? So you see for each of these, I have log base 10 written. And of course I did that because we're learning how to rewrite them. And if you're like me, I need to see it. So we could also write this as log 10,000 equals 4 without the base 10 showing because it's common logarithm. Same here. And of course, same here. All right.